Welcome back for another flight computer video. Today we're taking a look at the Aristo Aviat 616 produced by Aristo in 1956, also called the Aristo Aviat Model G. Now, the Aristo Aviat was only around for a short period of time, and to get some context, the Philip Dalton's patent on the E6B had expired in 1954. And I suspect that the short life for the Aristo 616 could have been related to other active patents at the time. And evidence of this is that Jeppesen produced nearly the exact same flight computer, but not until 1966 after some of those other patents had expired. Instead, what Aristo did was they redesigned the 616 as the 617 flight computer with a pretty different wind solution that probably wasn't covered by patents at the time, and moved forward with their new design. So we'll take a look at that in a different video. So about the basic construction of this device. Well, first of all, it came in this nice zippered leather pouch. Quite nice, branded as well. And it had one side for the wind and one side for the calculator. And the calculator side is identical to the 615 and the 610 flight computers that we looked at in the last video. So all of that functionality is there, but compared to an E6B, one of the things that's really nice about the 616 is the addition of the cursor, which makes it easy to line up your answers for a bit more precision. Now, I will say this flight computer is in pretty rough shape. So we've got a chip to the plastic slide. Well, the whole device is made out of plastic, but we've got chips to the corners here. And you can tell on the back that the ink, the black ink, is pretty faded, almost getting difficult to read. And on top of that, some of the other ink has faded as well. So here we should have a gauge mark for 36 seconds that's begun to wipe away. If we look here at the pressure altitude calculations for, I should say, the airspeed calculations, you can tell that some of this paint has worn off, and you can almost see other scales underneath that, that worn off paint, which makes it a little bit difficult to use. So something to note if you're looking to pick up one of these devices is do check the condition and make sure that the paint is in good shape. And as another example, I have a 615 here that you can tell, first of all, the plastic has yellowed a bit, but the big surprising thing about this flight computer is that all of the blue gauge markings, so for liters, imperial gallons, or gallons, it's completely missing, completely not on there. I don't know if this was a misprint or if the blue ink had just wiped off, but also the altitude scale here for finding true altitude, that blue ink is entirely missing. So do take note of the quality of the paint when you're looking to purchase one of these devices. All right, moving on from there. So the back side of the device is much like an E6B. The difference being that we have these radials and these speed circles, wind circles, moving outwards from the center. And what that does is it eliminates the need to actually place a wind dot. You could just sort of visually infer winds coming from, say, 270 at 20 knots, and then you could set up your wind triangle accordingly. And that could be either a drift triangle, or that could be a wind correction angle like we normally do when we're doing our flight planning. But there's some, rather than just doing a standard wind triangle problem in this video today, what I thought we would do is something that actually takes advantage of this specific design, the 616 design. So what we'll do is we'll find the winds aloft given some other parameters. So let's just jump in. The first thing we know is that our true airspeed is 200 knots. So what we do is we set the grommet of the device, the center, right onto 200. And then our true heading is 050. So we would set 050 under the true index up the top of the device. And then after 1 hour, after flying over a checkpoint, we would note our difference, and we could see that we were 10 degrees left of course. So that means that we're going to be somewhere on this 10-degree drift line right here, and that our ground speed, given over the position of the checkpoint, was 177 knots. So what we would then do is follow the 10-degree drift line until it comes down to 177 knots, which is going to be right about here. Now, it's not necessary to make that wind dot. I've done it just to help clarify what's going on. Now, without turning the device or making any changes, we can just read where the wind is coming from here on the red ink, the reciprocal of the bezel. So the wind would be coming from 100, that would be our wind direction. And the wind speed, we could tally by just counting the circles outwards from the center. So it's be 10 knots, 20 knots, 30 knots, 40 knots. And that's all there is to it. By putting a wind dot there, then we could actually use that wind dot in additional wind calculations. And again, even though you don't have to put a wind dot with this particular design, I still think that it's a good idea. And if you're not too busy flying the airplane, just go ahead and make your wind dot. So that's all I wanted to cover for the Aristo Aviat 616, a relatively rare flight computer just because it wasn't produced for very long. In the next video, we'll take a look at the design that replaced it, which again is the Aristo 617, which had a much longer life and has some interesting features of its own. So that's all for today, and thanks for watching.